Hey guys, tonight we step outside beneath a sky that looks, at first glance, almost manageable. A few stars over the roofline, a faint wash of darkness above the trees. Maybe a porch light glowing behind you like it still believes it is contributing something to this situation. The air is cooler now, and the world has that late-hour softness where even familiar things seem to loosen their shoulders a little. Before you get cozy, take a moment to like the video and subscribe, but only if you genuinely enjoy spending time here with me. And while you're settling in, tell me your location and your local time down in the comments, because there is something deeply comforting about knowing where on Earth you're listening from while we look at everything that is not Earth. Let the world slow down for a moment. Let the fan murmur softly nearby, and let's slip into tonight's journey together. You stand there for a moment under the night, and the first relaxing fact is almost too simple to notice. Space does not begin far away. It begins here, above your head, so quietly that if you didn't know better, you might assume the sky is a ceiling instead of a depth. But the blue daytime sky and the black nighttime sky are not really two different places. They're the same direction, the same open up, the same vastness, just wearing different lighting. The universe has been hanging over your house all day long without making a fuss about it. Very polite, really, for something so absurdly large. The strange comfort comes from scale revealing itself gradually. You do not have to leap straight from your street to the edge of time. You could begin with something small and human. A house, a neighborhood, a town glowing gently on a map. Then a country, a coastline, a continent. Earth itself. That feels big enough to keep most brains busy. And yet Earth, for all its weather and oceans and mountain ranges and opinions about parking, is a modest little sphere in a much larger arrangement. Imagine holding Earth in your mind as a globe. Not a dramatic globe, just one you could rest in your hands, turning it gently with your fingertips. Every city, every road, every late-night kitchen light, every train station, every dog barking at absolutely nothing, all of it fits on that one round object. And if you place the moon beside it to scale, the moon would be smaller than most people picture and much farther away than our storybooks implied. If Earth were the size of a basketball, the moon would be about the size of a tennis ball sitting several feet away. Already space is doing its favorite trick, making things both adorable and ridiculous. That distance between Earth and moon is one of the first cosmic facts that can settle your thoughts rather than stir them up. The average gap is about 30 Earths lined up side by side. 30 entire planets. You could fit every one of them in the space between us and that pale, familiar companion that has been decorating poems for thousands of years. And yet when you look up, the moon feels close. It feels personal. It feels like something that has checked in on you before. Space is very good at disguising enormity as companionship, and that is one reason the sky can feel so restful. The biggest things rarely announce their true size. They do not stomp into view like action movie monsters. They shimmer, they glow, they hang there with the confidence of old furniture. A star can be immense beyond reason and still appear no more alarming than a pinprick. The cosmos, for all its scale, has excellent bedside manners. Even light, the fastest thing we know, gives the universe a kind of softness. Moonlight is old by the time it reaches you, but only by a little, roughly a second and a quarter. Sunlight takes about 8 minutes to arrive. So when you feel the warmth of late afternoon on your skin, you're feeling something that left the sun while you were still doing something ordinary and mildly unnecessary, like searching for your keys when they were in your hand the whole time. The sky is never entirely live. It is always arriving. That delay makes the universe feel less like a machine and more like a long, slow conversation. The stars overhead deepen that feeling. Most of the brighter ones you can see with your own eyes are so far away that their light has been traveling for years, decades, sometimes hundreds of years before meeting you tonight. Which means the night sky is not a flat picture at all. It is layered time. One star's light may have begun its journey before you were born. Another may have started toward you while someone, somewhere, was lighting a lantern, writing a letter, missing a train, falling in love, burning toast. The universe is full of delayed arrivals, and somehow that makes it gentler. You do not need to memorize numbers for the comfort to work, but the numbers do help. Earth is about 12,742 kilometers across. That sounds large because it is. You could spend a lifetime not finishing with it. Yet compared with many things above you, Earth is less a grand kingdom and more a well-loved marble. There's a soothing humility in that. Your worries do not disappear exactly, but they stop behaving as if they own the place. Then there is the atmosphere, that thin blanket wrapped around Earth. From the ground, the sky feels endless. From space, the atmosphere is surprisingly delicate, just a narrow, glowing skin around the planet. All weather, all clouds, all wind, all the air you have ever breathed, all the storms dramatic enough to get their own names, happen in a layer so thin that on a scale down Earth, it would look like the faintest coat of varnish. You're living on a world protected by something slender and almost improbably effective. There is something calming about that, too. Fragile things can still hold. The farther you pull back in your imagination, the more Earth begins to look like a lantern in a huge dark room. Not a lonely lantern, just one bright point in a place roomy enough for everyone. That darkness between worlds is not empty in the emotional sense. It is spacious. It gives things room to glow. Without all that dark, stars would have nowhere to be stars. Space is generous that way. It does not crowd the scene. And maybe that is why looking up can lower the temperature of the mind. Human life is dense. Notifications, errands, conversations, bills, schedules, the immortal mystery of why one sock always disappears. Everything is close. Everything touches everything else. But overhead, distances are so large that events unfold with almost ceremonial patience. Planets keep their lanes. Moons keep their rhythms. Light travels on and on without hurrying. No one in the Orion constellation is frantically checking email. A useful model, frankly. The constellations themselves offer a nice little illusion to rest on. From Earth, they look like neat patterns, ancient dot-to-dot drawings made by civilizations that understandably wanted the sky to cooperate. But the stars in a constellation are usually not neighbors in the way they appear. They only line up from where you happen to be standing. Move to another place in the galaxy, and the patterns would distort, bend, or disappear. So even the shapes you know in the sky are a kind of perspective trick, a reminder that your viewpoint matters, but is not the whole story. That can be unexpectedly reassuring. You are allowed to have one partial window onto reality. Everyone does. And still, partial as it is, your window is beautiful. You can stand in one spot on one planet and see enough to understand that the universe is bigger than instinct was designed for. Bigger than architecture, bigger than weather, bigger than empire, bigger than memory, bigger than any map that ever thought highly of itself. Yet the emotional effect of that bigness does not have to be fear. It can be release. Because when the universe is this large, it can hold unfinished things. It can hold your questions without demanding instant answers. It can hold whole ages of silence, whole fields of stars, whole distances so wide that language starts rubbing its eyes and asking for 5 more minutes. The sky does not ask you to solve it tonight. It only asks you to notice it. And notice how gentle the transition is from the familiar to the impossible. First the roofline, then the stars above it, then the thought that every star might be a sun, then the realization that the darkness between them is not a gap in the picture, but part of the picture, then the sense, slow and steady, that your little patch of night is connected to everything, not metaphorically, literally. The atoms in your body were forged in ancient stars. The iron in your blood, the calcium in your bones, the oxygen filling your lungs, all come from processes larger and older than any human story. You are not just under the universe. You are made of the same long material. That is one of the most relaxing truths you can carry into the night. The biggest things in space are not alien to you in the deepest sense. They are relatives at an absurd scale. Distant, radiant, slightly dramatic, yes, but family. And from your quiet place under the sky, with the world dimming and the room behind you fading into stillness, you can let that thought settle softly. The porch light glows. The stars wait. The universe, outrageously huge and weirdly tender, keeps unfolding above you without ever raising its voice. That same quiet sense of scale carries you a little farther out now, past the moon's familiar company and beyond the rocky inner worlds, until one planet begins to dominate the imagination with such effortless confidence that it hardly seems to be trying. Jupiter does not need to show off. It is the kind of giant that can enter a room simply by being the room. And yet, for all its size, it has a strange softness to it, a look that is less like a boulder and more like cream stirred into coffee, less like machinery and more like weather thinking very large thoughts. If you could see Jupiter hanging in the sky where the moon usually sits, it would be astonishing. Not just bright, not just impressive, but enormous enough to interrupt conversation for the rest of your life. It would appear several times wider than the full moon, a great striped lantern with subtle colors and a gravity to match its stare. Fortunately, for everyone hoping to maintain basic emotional stability, Jupiter stays sensibly far away. Space, once again, showing remarkable courtesy. The relaxing fact about Jupiter is not only that it is huge, it is that it is huge in a rounded, patient, almost pillowy way. This is not a sharp-edged giant. It has no cliffs for you to tumble from, no solid surface waiting to surprise your ankles. Jupiter is mostly hydrogen and helium, the same simple elements that make up stars, gathered into a world so massive that it became a kind of almost star, a planet standing right on the edge of something even more dramatic, and then deciding, very calmly, not to be extra about it. Its diameter is about 11 times that of Earth. If Earth were a grape, Jupiter would be closer to a grapefruit. And that is just the width. In volume, more than 1,300 Earths could fit inside Jupiter. Imagine every ocean, mountain, city, forest, airport, wedding reception, tea kettle, traffic jam, and sleepy little porch from Earth, and then imagine over 1,000 worlds like that fitting into one planet. It is almost rude, but Jupiter carries that excess so gracefully that it feels less intimidating than soothing, like a giant cushion drifting through dark water. And yet, even being that large, Jupiter is not the heaviest thing it could possibly be. Its mass is about 2.5 times that of all the other planets in our solar system put together. One planet outweighing the rest of the planetary family combined is a very Jupiter move. Not arrogant, exactly, just deeply aware of its own presence, like a cat sitting in the exact middle of a keyboard and pretending this is accidental. When you picture Jupiter, you probably picture the bands first. Those soft horizontal stripes wrapping the planet are belts and zones, long atmospheric rivers circling the globe at different speeds and in different directions. They make Jupiter look brushed, painted, layered. Beige, cream, rust, pale gold, a little salmon, hints of white. Nothing about its palette screams for attention. It is not neon. It is not trying to be the universe's nightclub flyer. It is elegant in an old, weathered, low-voiced way, like a giant planet that understands lighting. Those bands are made visible by clouds composed of different chemicals at different altitudes, ammonia and other compounds rising and sinking in the deep atmosphere. The colors come from chemistry and sunlight and processes still not entirely pinned down, which is honestly very on brand for space. The universe loves to say, here is a breathtaking phenomenon, and by the way, we are still sorting out the details. But uncertainty does not ruin the beauty. It often improves it. Then there's the Great Red Spot, the famous storm on Jupiter that has been raging for centuries. A storm so large that Earth could fit inside it, although not with much dignity. You hear that fact and expect menace, because on Earth storms arrive with broken umbrellas and strongly worded weather alerts. But on Jupiter, the Great Red Spot feels different. It swirls in place like a cosmic eye half closed with sleep, a giant atmospheric whirlpool turning and turning in no special hurry. It is violent in physical terms, certainly, with winds far faster than anything you would want in your neighborhood, but from a distance it looks serene. That is one of space's favorite tricks again. Tremendous energy expressed as quiet beauty. And Jupiter is full of storms besides that one. Its atmosphere boils with vortices, eddies, pale ovals, chaotic curls, and little spinning tempests that merge, fade, and reform. The whole planet is weather without a ground beneath it, movement without a floor, currents stacked upon currents in layers thousands of kilometers deep. If Earth's atmosphere is a thin shawl around a solid world, Jupiter is atmosphere as architecture. Weather is not happening on Jupiter. Weather is Jupiter. That idea can be deeply calming if you let it. On Earth, weather feels temporary because it passes over things. Rain falls on roads. Wind moves through trees. Snow lands on rooftops, and your one parked car that somehow accumulates the entire storm personally. But on Jupiter, there is no neat separation between world and weather. The clouds are the face of the planet. The motion is the identity. It is a reminder that not everything needs a fixed surface underneath to be real. Some things are allowed to be all process, all flow, all continuous becoming. Jupiter also spins astonishingly fast. Despite being the largest planet in the solar system, it completes a rotation in roughly 10 hours. So its day is less than half an Earth day. This rapid spin stretches the planet slightly, making it bulge at the equator and flatten at the poles. Even giants, apparently, can be a little squashed by their own enthusiasm. The image is oddly charming. Jupiter, colossal and dignified, rotating so fast it cannot remain perfectly round. No one is flawless, and that fast spin helps shape its powerful magnetic field, one of the strongest planetary magnetic fields in the solar system. Jupiter's invisible magnetosphere is immense, extending millions of kilometers into space and forming a huge protective and dynamic region around the planet. If you could see magnetic fields the way you see clouds, Jupiter would look even more enormous than it already does. It wears a vast, unseen cloak, rippling and responding to the solar wind. A giant not only with a body bigger than reason expects, but with an invisible reach stretching much farther still. Its moon system adds another layer of grandeur. Jupiter does not wander alone. It travels with a whole miniature solar cord of moons, dozens upon dozens of them, from tiny irregular captured rocks to major worlds worthy of stories all their own. The four largest, Io, Europa, Ganymede, and Callisto, were the first moons discovered orbiting another planet, and they remain some of the most fascinating places in the solar system. Ganymede is the largest moon of all, even bigger than the planet Mercury. Europa hides a global ocean beneath its ice. Io erupts with volcanoes. Callisto bears ancient scars from impacts. Jupiter gathers extremes around itself the way a bonfire gathers moths. There is something restful in imagining that arrangement from far away. Jupiter at the center, broad and banded, with moons circling in measured silence. Everything moving, everything held, gravity functioning like a kind of music, invisible but strict, turning open space into choreography. No one has to argue over directions. No one is missing the exit. The system simply continues, hour after hour, century after century, with the calm confidence of a watch too large to fit inside time properly. Jupiter also plays a protective role in the solar system, though not in the simple, heroic way it is sometimes described. Its gravity can deflect or redirect comets and asteroids, and it has likely influenced countless objects over billions of years. Sometimes it shepherds danger away. Sometimes it flings things inward. Jupiter is not a bodyguard in sunglasses. It is more like a giant gravitational diplomat, rearranging trajectories with a massive hand and not always filing clear paperwork. But overall, Its presence shapes the architecture of the solar system in ways that helped make the inner planet's story what it is. Even its light is borrowed gently. Jupiter does not blaze with its own visible fire like the sun. It shines mostly by reflecting sunlight, a soft pale glow in the dark. When you see Jupiter in the night sky with your own eyes, what you're seeing is sunlight that traveled from the sun to Jupiter and then from Jupiter to you, crossing vast distances just to become one steady point in your evening. That is somehow tender. A giant planet glowing by reflection, content to be radiant without insisting on being the source. And if you were somehow able to descend into Jupiter's atmosphere, things would become stranger and stranger. The pressure would rise. The gas would grow denser. Hydrogen would eventually behave in exotic ways under tremendous compression, becoming metallic deep inside, a form of matter unlike the ordinary gas you picture from balloons and awkward party decorations. Somewhere far below the visible clouds, Jupiter becomes a world of immense pressure and heat, a place where familiar categories blur. Yet from above, all you would see is that calm marbled surface, those soft ribbons of cloud, that old persistent storm, which makes Jupiter oddly comforting as a symbol. It is a reminder that the largest things do not always need hard edges to be powerful. Vastness can be striped and luminous. Strength can be fluid. A giant can wear pastel colors. The biggest planet in your cosmic neighborhood looks less like a weapon and more like a sleeping thought. So you hold Jupiter in mind for a while, not as a fact sheet, but as a presence. A warm-toned globe turning quickly in the dark. A world of bands, storms, moons, and hidden depth. A giant that reflects light instead of hoarding it. And somewhere behind that image, you can still feel that first quiet porch-light perspective from earlier, still standing under the sky, realizing that above your roofline drifts a planet big enough to fit more than 1,000 Earths, yet gentle enough to appear as one steady, peaceful point of light. From that banded giant and its slow court of moons, your attention keeps moving inward again toward the one object in the solar system so familiar that you almost have to trick yourself into seeing it clearly. The sun is the great everyday miracle people routinely ignore because it arrives on schedule. It rises, pours gold over rooftops, warms the pavement, illuminates laundry that no one wanted to fold, and generally behaves with such consistency that it gets treated less like a star and more like a utility. Very unfair, really, because the sun is not just a bright object in the sky. It is an enormous sphere of hot plasma, so large that if you truly pictured it properly, you would never look at a sunny afternoon quite the same way again. The most relaxing thing about the sun's size is that it hides inside normal life. You can be standing at a crosswalk, sipping tea by a window, or squinting at dust floating in a beam of morning light, and all the while you're being nourished by a star that contains about 99.8% of the mass of the entire solar system. Nearly everything else, every planet, moon, asteroid, comet, every rock with ambition, all of it together makes up only a tiny leftover fraction. The sun is the central fact around which everything else politely organizes itself. If Earth is that well-loved marble from earlier, then the sun is a sphere so wide that about 109 Earths could fit lined up across its diameter. Not around it, across it. And in terms of volume, you could fit roughly 1.3 million Earths inside the sun. 1.3 million. It is one of those numbers that does not so much enter the mind as lean against the outside of it and wait. You can say it aloud, but the imagination still needs a minute to sit down. And yet, despite being incomprehensibly huge compared to Earth, the sun is not a particularly giant star by broader cosmic standards. That fact can be strangely calming too. In your own neighborhood, the sun is overwhelmingly dominant. In the wider universe, it is more middle management. Competent, stable, dependable, not flashy, not trying to become the office legend. The sun is large enough to sustain life, modest enough not to be a hyperactive monster, and steady enough to let oceans persist and trees keep doing their patient tree business. It is, in stellar terms, reassuringly ordinary. That ordinariness is a gift. The Sun belongs to a class called main sequence stars, which means it spends most of its life fusing hydrogen into helium in a relatively stable balance. Gravity presses inward. Heat and radiation push outward. These forces hold each other in check with exquisite patience. And the result is a star that has been shining for about 4.6 billion years without turning every day into a melodrama. A very professional performance. Its light feels immediate, but like everything in space, sunlight takes time. About 8 minutes and 20 seconds pass between light leaving the sun's visible surface and reaching Earth. So every sunrise you have ever seen was already a little old on arrival. Not stale, just traveled. The sunlight warming your hands at breakfast left the sun before you poured the coffee, before you checked the weather, before you remembered that one awkward thing you said 7 years ago. Light was already on its way, crossing 150 million kilometers of space with no need for applause. That distance between Earth and Sun is called an astronomical unit, which sounds elegant until you realize astronomers basically said, this distance happens a lot. We are naming it after itself. Still, there is something soothing in knowing there is a standard cosmic yardstick based on the gap between your world and its star. It gives the solar system a certain domestic feel, as if someone finally labeled the measuring cups in the kitchen. If you could place the sun next to Earth in a way your brain could handle, the comparison would still be absurd. A common scale model helps. If the sun were a large front door, Earth would be roughly the size of a coin. That familiar little world of continents, traffic, weather, and endless opinions about which pillow is best would become something tiny enough to misplace in a couch cushion. And the moon would be even smaller, nearby, but visibly secondary, like a speck accompanying a speck. The scale is humbling, yes, but also oddly tender. Life flourishes on something so small beside something so vast. The sun's surface, or more properly the photosphere, is around 5,500 degrees Celsius. But surface is a courtesy term. The sun is not solid. There's nowhere to stand, nowhere to put down a picnic basket and immediately regret it. It is plasma, a state of matter where atoms have been stripped into a roiling sea of charged particles. That sounds intense, because it is, and yet when you picture the sun from a safe, imaginative distance, it can feel astonishingly serene. A smooth golden disk, a quiet coin of light through haze, a warm wash across a room, enormity disguised as comfort again. Beneath that visible surface lies the core, where the real business happens. There the temperature climbs to around 15 million degrees Celsius, and hydrogen nuclei fuse into helium, releasing energy that will work its slow way outward. What is especially wonderful, in a sleepy, mind-loosening way, is how long that energy takes to escape. The photons produced in the core do not zip neatly to the surface. They are bounced, absorbed, re-emitted, jostled around in the sun's dense interior, wandering in a kind of chaotic shuffle that could take tens of thousands to hundreds of thousands of years before the energy finally emerges as sunlight. A beam of sunshine on your wall may contain energy whose outward journey through the sun began before human civilization had done most of its decorating. And when that energy finally escapes, it spreads with lavish generosity. The sun radiates in all directions, not aimed, not selective. It shines outward into space, whether a planet happens to be there or not. Earth receives only a tiny fraction of that output, and yet that fraction powers weather, drives climate, feeds plants, and by way of plants and food chains and all the clever chemistry of life, supports the existence of you listening to this right now. A tiny share of a star's spillover created forests, plankton, wheat fields, mangoes, coral reefs, and people who look at the sky and get pleasantly overwhelmed. The sun also has a soundless majesty in its structure. It is layered, but not with the neat, tidy divisions of a textbook cake. There is the core, then the radiative zone where energy creeps outward, then the convective zone, where hot plasma rises and cooler plasma sinks in immense bubbling currents. Above the photosphere lies the chromosphere, and above that the corona, the sun's outer atmosphere, which extends far into space and becomes visible during a total solar eclipse as a ghostly white halo. The corona is one of the loveliest oddities in astronomy because it is far hotter than the visible surface below it, which is exactly the sort of thing the universe does when it wants to remind you that reality is under no obligation to arrange itself according to beginner expectations. Sunspots mark cooler, darker regions on the photosphere, created by intense magnetic activity. They come and go in cycles, and their changing number reflects the sun's magnetic rhythm. They make the sun look briefly textured, imperfect, active in a way you can almost imagine. Not a flawless lamp, but a living star with moods and patterns. Solar flares and coronal mass ejections can erupt from this magnetic complexity, sending charged particles streaming through space. These can interact with Earth's magnetic field and paint the polar skies with auroras, those soft green and red curtains that make the heavens look like they are remembering silk. There is such comfort in that chain of connection. Activity on the sun, 150 million kilometers away, can ripple all the way to Earth and become colored light above snowy fields and dark northern seas. A star stirs, a sky glows. People look up in silence. The biggest things often reaching not by force, but by beauty. And the sun's reach is larger still. Beyond the planets lies the heliosphere, a vast bubble carved by the solar wind into interstellar space. The sun is not only a bright center, it creates an enormous domain around itself, a kind of stellar weather sphere stretching far past Pluto. Even where its visible light has grown thin, the sun's influence continues. It shapes a region of space so large that the whole planetary system rides inside it like a family traveling in a radiant, invisible caravan. Yet for all that scale, your relationship with the sun remains personal. It is the reason for shadows on the floor, the reason for dawn birds beginning entirely too early, the reason leaves can turn light into sugar, the reason stone warmed all day still holds a trace of heat at dusk. You do not encounter the sun as an abstract equation first. You encounter it as warmth on your face, as a room slowly brightening, as evening softening into gold. The star that could swallow 1.3 million Earths introduces itself by touching your windowsill. That contrast may be the sun's most relaxing fact of all. It is almost unimaginably large, but it reaches you in delicate ways. Through brightness filtered by curtains, through a rectangle of light on a wooden floor, through the brief warmth on your arm when the clouds part, through the soft orange of late afternoon when everything looks a little kinder than usual. The biggest nearby thing in space is also the gentlest daily companion, and maybe that is why the sun never quite feels monstrous, even when you know the numbers. Its immensity is softened by rhythm. Day after day, season after season, it appears with a steadiness that lets nervous creatures build homes, plant gardens, invent calendars, and pretend they understand mornings. It asks almost nothing of you except notice. Not even constantly. Just once in a while, perhaps when sunlight lies across a table in such a peaceful way that you remember this warm quiet came from a star vast enough to dominate the solar system and patient enough to do so without noise. So you let the sun settle into your imagination not as a blinding ball of science fair drama, but as a huge, stable heart at the center of familiar space. A sphere of plasma held in balance. A source of light that wanders outward over ages before finding your world. A giant so large it makes Jupiter seem suddenly manageable, and yet so gentle in daily life that it can be mistaken for ordinary weather. And while the night continues around you now, the memory of sunlight remains close, as if even in darkness you are still carrying a little of that quiet enormity forward. And once you have let the sun take its proper place in your mind, enormous yet familiar, It becomes even more delightful to meet the stars that make it look almost modest. Not weak, not unimportant, just suddenly very sensible. The sun is like the sturdy lamp in your living room, warm and reliable. And then somewhere farther out in the galaxy, you discover chandeliers the size of nightmares. Except they are beautiful, so the nightmares never quite get started. These are the supergiants and hypergiants, stars so large that your ordinary comparisons begin to stretch and yawn and ask whether they might lie down for a bit. You cannot really understand them in one glance, because the mind likes stars to be points of light, compact and tidy, the way they appear overhead. But some stars are so huge that if one replaced the sun at the center of your solar system, its swollen outer layers would extend past the orbit of Mercury, then Venus, then Earth, and sometimes beyond Mars. Suddenly, the cozy arrangement of planets starts to feel like furniture pushed back against the wall to make room for a guest who has arrived wearing an absurdly large coat. A red supergiant, such as Betelgeuse, gives you a good place to begin, because it is both famous and strangely tender in the imagination. It marks the shoulder of Orion, one of the easiest constellations to recognize, and from Earth it shines with a reddish glow that feels old and thoughtful. Betelgeuse is not merely brighter than the sun. It is physically vast, hundreds of times wider. If placed where the sun is, its outer atmosphere would reach somewhere around the orbit of Mars, depending on exactly how you define its edge, which is only fair because stars this large are not exactly crisp about boundaries. Their outer layers are diffuse, extended, and faintly indecisive. When a star becomes enormous enough, even its edges seem sleepy. That is one of the most relaxing facts about the biggest stars. They're not hard little diamonds. They're soft giants, puffed up and luminous, more like glowing fog held together by gravity than solid objects with neat rims. The larger some of these stars become, the lower their average density can be. A red supergiant can contain a tremendous amount of matter spread across such an immense volume that, in a sense, it is less tightly packed than you might expect. Vastness does not always mean heaviness in the way your instincts assume. Sometimes it means expansion, looseness, a great ballooning into space. Betelgeuse is also a variable star, which means its brightness changes over time. It subtly swells and contracts, brightens and dims, not because it is indecisive in a dramatic soap opera way, but because stars are living physical systems, dynamic and restless under their calm appearance. Betelgeuse had a famously noticeable dimming not long ago, which made everyone briefly wonder whether it was preparing to explode as a supernova. It turned out to be less apocalyptic than that, a reminder that even giant stars can have dusty, complicated days. Honestly, relatable. Then there is Antares, the red heart of Scorpius, another supergiant with that same warm ember color. Antares is also hundreds of times wider than the sun. If the sun is a steady yellow-white note, Antares is more of a deep cello tone in the sky, broad and resonant. These red supergiants are cooler at the surface than the sun, which sounds backwards if you are still equating size with intensity. But that is the lovely trick. A bigger star can glow redder and cooler on the outside precisely because it has expanded so enormously. It is like heat spread across a vast curtain instead of concentrated in a small flame. That spread-out glow gives them an almost domestic gentleness in photographs and imagination. They do not stab the sky with blue-white brilliance the way hotter stars can. They smolder. They radiate. They seem to breathe. Their light looks aged, patient, and slightly theatrical, like they are aware they have been cast in the role of ancient cosmic giant and have decided not to overplay it. But red supergiants are only one kind of stellar enormity. Blue supergiants are another matter altogether. Where red supergiants feel expansive and ember-like, blue supergiants are hotter, more compact relative to their luminosity, and dazzling in a way that borders on rude. Rigel, also in Orion, is a beautiful example. It It appears as a brilliant blue-white star, and though it may not be as physically bloated as Betelgeuse, it pours out vastly more energy than the Sun. This is where size in space becomes wonderfully slippery. A star can be bigger in radius, or bigger in mass, or immensely brighter, and those are not always the same contest. The universe refuses to keep things simple just when you thought you had a neat ranking system. Very on brand. Rigel is tens of thousands of times more luminous than the Sun. Imagine replacing your ordinary household bulb with a lighthouse, then replacing the lighthouse with a small, offended deity, and you're still not really there. In the sky, Rigel shines as one elegant point. Again and again, the cosmos teaches the same soothing lesson. Enormous realities can arrive in delicate forms. And then, because apparently moderation was never the galaxy's main hobby, you encounter the hypergiants. Even the name sounds like someone in astronomy briefly gave up on subtlety. A hypergiant is one of the most luminous and massive kinds of stars known. A star living fast, burning intensely, and shedding material in powerful winds. These are not calm, long-lived stars like the Sun. They are extravagant. They are stellar opera. They stride onto the stage with capes made of plasma and leave the set damaged. One famous example is VUI Canis Majoris, a red hypergiant often mentioned among the largest known stars by radius. It is difficult to define its exact size because, again, these outer layers are extended and complex, but it is huge beyond comfortable description. If placed at the center of your solar system, its visible bulk would reach past the orbit of Jupiter. Think about that for a moment. Mercury gone, Venus gone, Earth not just swallowed, but forgotten under the table. Mars gone, the asteroid belt politely erased. Jupiter itself suddenly much too close for comfort. The scale is so excessive that it stops feeling threatening and starts feeling absurd in the best possible way. Space occasionally becomes so grand that it loops around into softness. UY Scuti is another star often named in these discussions, possibly among the largest known by radius, though the exact measurements are uncertain because stars this immense do not sit still for neat portrait sessions. Their atmospheres are extended, their distances can be tricky, and astronomy is often doing its best with light that has crossed staggering emptiness. But whether UY Scuti is first, second, or somewhere in that ridiculous upper tier, the point remains. The universe contains stars so large that your entire planetary system could curl up inside them like a cat on a cushion. What makes these stars especially soothing to imagine is that their bigness is not cleanly geometric. They are not giant billiard balls. Their surfaces can be lumpy with convection cells, so large they dwarf worlds. On the Sun, convection creates granules. On a red supergiant, those bubbling cells can be vast, each one covering a significant fraction of the star's visible face. Imagine a star whose weather patterns are larger than planetary orbits. It is weather the way Jupiter was weather, except now the weather is happening on a star that could swallow Jupiter's whole neighborhood. The scale becomes dreamlike. Their lives, though shorter than the Sun's, carry a kind of intense beauty. Massive stars burn through their fuel much faster. The bigger and more massive they are, the shorter and more dramatic their existence tends to be. A star many times the Sun's mass may live only millions of years instead of billions. That sounds tragic only if you insist on judging stars by human standards. In cosmic terms, these are brilliant brief performances, great banners of light unfurled across the galaxy. They do not linger. They blaze, expand, pulse, shed their outer layers, and eventually die in some of the most powerful events the universe can manage. But even that future does not disturb the calm too much tonight, because what matters here is their present grandeur. From far away, they are serene. Their violence is hidden inside radiance. Their instability is translated into color and brightness. They remind you that not all greatness is tidy, and not all instability is ugly. Some of the most magnificent things in existence are magnificent precisely because they are temporary, because they are spending themselves lavishly in light. And there's a humbling sweetness in how these giants make the sun look. The sun, which could fit 1.3 million Earths inside itself, which dominates the solar system so completely that all the planets together amount to crumbs by comparison, now seems modest beside these stellar behemoths. Yet that does not diminish it. It only places it in a wider choir. Your star is one voice among many, and somewhere out there are deeper voices, louder voices, stranger voices, all singing in different sizes and colors across the galaxy. When you look up at Orion now, knowing Betelgeuse and Rigel are there, you're not just seeing pretty points. You are seeing two very different answers to the question of how a star can be immense. One cool and swollen, reddish and soft-edged. One hot and brilliant, blue-white and intense. The sky is not repetitive. It is varied the way a forest is varied, or an ocean, or a shelf of old books. Similar in form, wildly different in detail. And perhaps that is the quiet gift of these enormous stars. They expand your sense of what big can mean. Jupiter was big in a round, weather-filled way. The sun was big in a stable, life-giving way. Supergiants and hypergiants are big in a more extravagant register, all atmosphere and radiance and impossible scale. And yet even they are not the end of the story. They shine within larger environments, inside larger structures, nested in bigger darknesses still. So you hold them for a moment in the same gentle mental space where the porch light first met the cosmos. Betelgeuse glowing like an ember, Rigel burning blue-white, Antares pulsing warm and red, VY Canis Majoris and UY Scuti bloated to dimensions that make planetary orbits look like afterthoughts. Stars so huge they make suns blush, and yet from Earth they arrive as small, quiet lights, patient enough to fit above a sleeping world. From those swollen stars with their soft edges and their impossible radius, your attention keeps moving outward, and the strangest thing happens. The universe stops looking like a collection of objects and starts looking like a painting. Not a neat little frame landscape, either. More like a mural the size of thought itself, brushed across darkness in slow motion, with color drifting into colors so gradually that even time seems to sit down and lower its voice. This is where you meet the giant clouds of space, the nebulae and star-forming regions so large that your ordinary sense of distance begins to lose its sharp corners. On Earth, clouds are temporary. They gather over hills, cross a city, change shape while you're still deciding whether it will rain, and generally behave like moody decorators. In space, clouds can be vast enough to span dozens or hundreds of light years. They do not hurry anywhere. They do not blow past before lunch. They linger. They glow. They become nurseries for stars. A nebula is, at its simplest, a cloud of gas and dust in space. But cloud is doing a lot of work there, rather like calling Jupiter some weather. These are not fluffy little things floating past a sunset. A giant molecular cloud, the kind where stars are born, can contain enough material to form thousands or even millions of suns. It can stretch across such enormous distances that light itself needs years just to cross from one side to the other. Which means the cloud is not merely large. It is so large that the fastest thing in the universe takes its time in there. And already, that changes the mood. In the presence of a nebula, speed seems almost impolite. These regions are built for patience. They do not make stars like a machine, stamping out identical parts. They gather, cool, collapse, fragment, and shine in a process so extended and elegant that slow stops sounding like a delay and starts sounding like wisdom. The Orion Nebula is one of the most famous examples, partly because it is relatively nearby in cosmic terms, and partly because it is so beautiful that even the universe seems slightly pleased with itself over that one. You can find it in the sword of Orion, below the belt, a faint fuzzy patch to the naked eye under decent skies. That little smudge, which from Earth can look almost modest, is actually a vast stellar nursery where new stars are forming. It lies about 1,300 light-years away, and the glowing cavity you see is only one bright region inside a much larger complex of gas and dust. It is worth lingering on that phrase, larger complex, because space loves nesting dolls. The Orion Nebula is not just a cloud. It is part of the Orion Molecular Cloud Complex, an enormous star-forming region spanning hundreds of light-years. The bright part you notice is like seeing one lit window in an entire sprawling building. Behind it and around it are darker clouds, filaments, ridges, and hidden pockets where gravity is quietly gathering matter into future suns. The pretty glow is only the visible portion of a much grander process. Space is very fond of showing you the tip of an iceberg, and then casually revealing the iceberg is the size of a continent. Inside regions like Orion, stars are born when parts of the cloud become dense enough for gravity to take over. A knot of gas begins to collapse. It heats as it contracts. Material falls inward. A protostar forms, still wrapped in its cocoon. Over time, if it gathers enough mass, the pressure and temperature in its core rise high enough for nuclear fusion to ignite. And just like that, though not actually just like that, because this takes ages, a star switches on. In the same broad cloud, hundreds or thousands of these births can happen in loose association, each one embedded in dust and gas, each one contributing a little more light, a little more heat, a little more sculpting power to the surrounding region. That sculpting is part of what makes nebulae so visually soothing. The massive young stars that form inside them pour out ultraviolet radiation and stellar winds. These streams of energy carve cavities in the surrounding gas, compressing some regions, eroding others, creating pillars, arcs, shells, and folds. The cloud becomes architecture, not rigid architecture like a bank or a parking garage, but flowing, cathedral-like architecture, all soft edges and luminous openings. The universe does not just make stars. It decorates the nursery. Think of the pillars of creation in the Eagle Nebula, perhaps the most famously photographed columns in space. They look like towering fingers of dark dust and gas rising into a glowing field, and they are enormous beyond human instinct. Each pillar is several light years long. Several light years. A structure so huge that if one end emitted light today, the other end would not receive that news until years had passed. And still, in images, they look calm enough to hang over a sofa. Space has a mischievous sense of interior design. Those pillars are regions where denser gas resists being blasted away as quickly as its surroundings. Inside them, new stars can form. So even their dramatic shapes are not just decoration. They are active cradles, weathered by radiation, hiding life cycles in dust. The image feels restful because it looks still, but it represents motion, pressure, light, evaporation, collapse, and emergence happening all at once on timescales too long to feel frantic. The most chaotic processes in the universe become serene if you stretch them over enough time. The same is true for the Carina Nebula, one of the largest star-forming regions in our galaxy. It spans hundreds of light years and contains multiple clusters of young, massive stars. Carina is less a single object than a grand district of stellar creation, a place where radiation sculpts towering dust structures and where enormous stars blaze like lanterns in a mist-filled valley. If the Orion Nebula is a beautiful room in the house, Carina is an entire wing, dramatic and ornate, with high ceilings and a budget no museum could ever secure. And then there are the dark nebulae, which do something even more relaxing. They withhold. Instead of glowing, they blot out light behind them. These are dense clouds of dust and gas seen in silhouette against richer star fields or bright emission nebulae. They appear as black rivers, curling walls, dark knots, and lanes crossing the Milky Way. Their beauty comes not from what they show, but from what they conceal. There's something deeply restful in that. Not everything enormous needs to shine. Some great presences in the universe are known by the light they gently interrupt. You can imagine drifting past one of these dark clouds and seeing stars disappear behind it. Not because the stars have gone, but because the dust between you and them is thick enough to block the view. It is the cosmic version of curtains drawn against a bright morning. Very relatable, very necessary. Dust in these regions is another marvelous detail. The grains are tiny, often comparable in size to smoke particles, made of silicates, carbon compounds, ices, and other materials. Tiny ingredients, colossal result. Billions upon billions of specks spread across vastness, shaping light into visible structure. It is a reminder that the biggest things in space are often made from the smallest pieces, arranged patiently. A nebula is not a block. It is a hush made of particles. Some nebulae glow because their gas is ionized by nearby hot stars. These are emission nebulae, often reddish because hydrogen, the most abundant element, emits characteristic light. Others reflect starlight, creating blue reflection nebulae where dust scatters shorter wavelengths more effectively. So the colors are not arbitrary. The red and blue veils in cosmic images are physical stories about energy and dust and the way light behaves. Even the prettiness is doing science, very efficient, and yet the real emotional effect is gentleness. The colors blend. The edges feather into darkness. Nothing in a nebula seems rushed or angular. Even when violent processes are involved, the view is soft. Compare that with everyday life, where a drop spoon can sound like a crisis and a calendar notification can feel like a personal attack. In a nebula, entire stars are being born, and the whole scene still looks like a sigh. There are giant molecular clouds in the Milky Way so extensive that they form the raw material for entire generations of stars. These clouds drift along the galaxy's spiral arms, denser where the galactic structure helps compress gas. The arms are not rigid lanes of fixed stars, but patterns through which gas moves, piling up and triggering star formation in places. So when you think of a spiral arm lit with bright young stars and nebulae, you're really thinking of a slow cosmic traffic pattern where clouds gather, collapse, and briefly bloom. Even the galaxy's large-scale structure seems to have moments of flowering, and that flowering is temporary in the loveliest way. A nebula can last millions of years, which is barely a pause to the universe, and more than enough time for every human empire to come and go several times while still failing to properly explain where all the matching socks went. Eventually, the stars at births blow away or consume the surrounding material. The nursery thins. The cloud disperses. The visible glow fades. But the stars remain, carrying the cloud's memory forward in their light. Planets perhaps forming around some of them. Future worlds built from the dust that once drifted in those luminous folds. That thought can settle you almost immediately. The grandest clouds in space are not only big, they are generative. Their immensity is not empty scale for scale's sake. It is fertile scale. Room enough for stars to happen. Room enough for systems, planets, chemistry. Maybe someday listeners under other skies wondering about their own porch lights and quiet evenings and strangely soothing giants overhead. So you keep floating through these painted distances for a while. Through Orion's glow, through the Eagle's pillars, through Carina's carved caverns, through dark lanes that close over starlight like velvet. Distance becomes texture. Light becomes weather. Dust becomes architecture. The universe starts painting in such enormous strokes that large no longer feels like the right word at all. It feels more like atmosphere or breath or the slow opening of something beautiful too vast to finish seeing in one lifetime. And from those painted nurseries, where stars begin as whispers in dust, you move naturally into places where starlight has already gathered itself into astonishing abundance. Not a few stars here and there, not the familiar scattered handfuls you recognize from backyard sky, but immense stellar neighborhoods so crowded and luminous that they begin to feel less like astronomy and more like architecture. This is where the universe builds cities, if cities were made of suns and silence, and a level of long-term planning no zoning board on Earth could ever hope to match. A globular cluster is one of the most soothingly extravagant things in space. It is a roughly spherical swarm of stars, tightly bound by gravity, containing tens of thousands, hundreds of thousands, sometimes even millions of stars all traveling together through the halo of a galaxy, like a self-contained lantern drifting around a much larger home. If the Orion Nebula felt like a nursery, full of soft beginnings and hidden cradles, a globular cluster feels like an ancient hill town at night. Every window lit, every street folded close, everything old and glowing and quietly sure of itself. The first relaxing fact is simply how old these places are. Many globular clusters are among the oldest known structures in a galaxy, with ages of around 10 to 13 billion years. Let that settle in. These clusters were already old when Earth was young, already old before dinosaurs ever took their first determined little steps, already old before continents arranged themselves into their modern moods, before oceans learned their current coastlines, before human beings were even a rumor. They have been circling their galaxies in patient arcs for almost the age of the universe itself. Some things do not rush. Some things endure with such calm longevity that your deadlines begin to look adorable. And because they are old, the stars inside many globular clusters tend to be older too. You do not usually find the hottest, brightest, shortest-lived young stars there in great numbers. Those would have burned out long ago. What remains is a population dominated by ancient stars, often yellowish or reddish, smaller and steadier, stars that have had time to settle into maturity. A globular cluster is not a fireworks display. It is more like a grand old library where everything glows softly and nothing needs to prove itself. Imagine one hanging in space, a great ball of starlight, dense at the center and feathering outward, every point a sun. Through a telescope, a bright globular cluster begins as a misty patch, then resolves into hundreds of pinpoints, then more, then still more, until it seems the cluster might never finish revealing stars no matter how carefully you look. The center is especially beautiful because the stars appear packed so closely that the cluster looks almost granular, like frost crystallizing on glass. It is one of the most delicate ways the universe expresses abundance. Messier 13, the great globular cluster in Hercules, is a classic example. It contains several 100,000 stars and lies about 22,000 light-years from Earth. To the eye through small instruments, it looks like a soft, luminous cotton puff. But that softness is deceptive. Inside is a crowded system of suns, each moving under the cluster's shared gravitational embrace. It is as though a whole town decided to become a snowfall and somehow kept its shape for billions of years. Now, imagine living in a world inside such a place. Astronomers and science fiction writers alike enjoy thinking about this, because the night sky from a planet in a dense star cluster could be extraordinary. Depending on where in the cluster you were, nearby stars might appear far brighter and more numerous than an Earth sky. Night might never be fully dark in the way you know it. There could be bright stars casting shadows, clusters of suns hanging like lamps in every direction, the heavens crowded not with emptiness but with company. It is a strange, lovely inversion of our usual cosmic image. Earth's sky teaches you that space is spacious. A dense cluster would teach you that space can also be communal. Of course, even crowded in astronomy still usually means stars separated by huge distances on human scales. The average gap between stars in the outer regions of a globular cluster may still be measured in fractions of a light year or more, vastly greater than anything you can truly inhabit with ordinary intuition. But compared with the space between stars near the sun, these separations are close indeed. In the cluster's core, the density can become immense, with stars packed thousands of times more tightly than in our local stellar neighborhood. Yet because space itself is so enormous, collisions between stars remain relatively rare. A A cosmic city still has plenty of elbow room. Very elegant, very considerate. Gravity is the mayor in these cities, though much more competent than most. It holds the cluster together, guiding countless stellar orbits in a shared system. Each star moves through the cluster's gravitational field, weaving a path that can take millions of years to complete. There is no traffic noise, no hurried footsteps, no one parallel parking badly. Just long, silent trajectories, endlessly adjusted by the collective pull of the group. You could think of it as a ballet, but even ballet sounds too quick. It is closer to drifting snow inside a glass globe the size of imagination. And the spherical shape matters too. A globular cluster is not a loose, flat scattering like many open clusters, the younger groups of stars often found in galactic disks. Open clusters are beautiful in their own way, more like associations or neighborhoods still remembering their common birth. But globular clusters feel complete, bound, self-contained. They are round because gravity has had time to work on them thoroughly, drawing the system into a balanced form, smoothing the distribution, letting the whole structure settle like cream into a bowl. That settling can be deeply calming to picture. The universe here is not exploding, collapsing, or dramatically shedding its layers as those hypergiants did. It is enduring. You can almost feel that history when you think of how these clusters orbit the Milky Way. They do not sit inside the spiral arms where gas and dust make new stars and painted ribbons. They dwell mostly in the galactic halo, passing above and below the disk in long looping trajectories. While the spiral arms glow with younger stars, nebulae, and that soft generative turbulence from earlier, the globular clusters travel farther out, like ancient lantern processions circling a grand dark palace. The galaxy contains both nursery and monastery, both bustling districts of creation and old remote citadels of memory. Omega Centauri is especially magnificent. Visible from southern skies, is the largest globular cluster associated with the Milky Way, containing millions of stars. Through a telescope, it looks like spilled diamonds gathered into a sphere. It is so large and unusual that astronomers suspect it may be the remnant core of a dwarf galaxy long ago absorbed by the Milky Way, which is another quietly delicious cosmic twist. One of the most beautiful star cities in our sky may be the surviving heart of a smaller galaxy, stripped down and carried inward over time. Space rarely throws anything away completely. It repurposes. It remembers in light. Then there are dense stellar regions nearer galactic centers, places where stars crowd together in numbers that make even globular clusters seem selectively edited. The center of the Milky Way is a rich and complex environment, with stars packed far more densely than around the Sun. There the gravitational field deepens, the population thickens, and the whole region hums with old stars, gas, dust, and the influence of the supermassive black hole at the core. Yet even there, the image from a distance is still one of luminosity, a thickening of the stellar city toward its heart. Galaxies like clusters have downtowns, and maybe that is why these structures feel so compelling. They mirror something human without becoming small. You know what it means for lights to gather in darkness. You know the comfort of seeing windows lit from a hill, a town glowing after sunset, a train full of people moving through the night, each one carrying a private world. A globular cluster takes that feeling and raises it to the scale of the stars. Not one house lit, but hundreds of thousands. Not one street, but a sphere. Not one century, but nearly all of time. The stars inside these clusters are not all identical, of course. They vary in brightness, mass, color, and evolutionary stage. Some are red giants, swollen and glowing warmly like miniature echoes of those great stellar elders from before. Some are fainter main sequence stars. Some are white dwarfs, the compact remains of stars that have finished their broader, shining lives. Together, they create a layered population, like a city where generations overlap and every building holds a different age of light. And the more you imagine it, the more the quiet grandeur settles in. A globe of ancient suns, held together for billions of years. A place where gravity gathers light into a form as beautiful as it is enduring. A stellar neighborhood so full that the darkness between stars becomes part of the design rather than the default. After the airy softness of nebulae, these clusters feel almost cozy, as if the universe, having shown you how to paint with clouds, now wants to show you how to build with stars. So you drift among these cities of stars for a while longer, letting their density soften rather than overwhelm. The porch light from the beginning seems very far away now, and yet not lost. It still belongs, because that was always the lesson hiding inside the scale. Whether it is one lamp by a house, one star warming a planet, or million suns gathered into an ancient sphere, light and darkness never really stops feeling like home. From those ancient stellar cities, glowing in their dense, spherical hush, you keep widening the view until even a globular cluster begins to look like what it really is. One bright ornament in a much larger structure. And that structure is your home galaxy, the Milky Way, a name so soft and old-fashioned that it almost tricks you into forgetting how enormous the thing actually is. Milky Way sounds like a dessert, or perhaps an overly optimistic lane name in a suburban development. In reality, it is a spiral galaxy containing hundreds of billions of stars, vast clouds of gas and dust, dark matter shaping its form from invisibility, old clusters circling in the halo, and at its hidden heart, something so powerful that stars race around it, as if late for an appointment they cannot refuse. And still, when you look up on a very dark night far from city lights, the Milky Way does not feel aggressive. It appears as a pale river across the sky, a wash of soft brightness, almost like breath on black glass. That is one of its most relaxing qualities. A galaxy can be staggeringly huge and still introduce itself as a whisper. You are inside it, of course, which complicates the view beautifully. You cannot step outside the Milky Way for a family portrait. You see it from within the disk, as one embedded creature among many, looking along the crowded plain where stars, gas, and dust thicken into that luminous band. It is a bit like trying to understand the shape of a forest while standing among the trees, except the forest is about 100,000 light years across and made of suns. So not your average hiking problem. That width alone is calming in an almost absurd way. Light, which already crossed the Orion Nebula's nursery halls and the gaps between stars and globular clusters with effortless dignity, would still need roughly 100,000 years to travel from one side of the Milky Way's disk to the other. Not because it is being lazy, because the galaxy is simply that broad. Imagine sending a beam of light across your galactic home and having it remain en route longer than all recorded human history by a factor so large it becomes embarrassing to compare. Suddenly, I'll do it tomorrow feels much less dramatic. The Milky Way is a barred spiral galaxy, which means that rather than having its spiral arms begin neatly from a round central bulge, it has a bar-shaped concentration of stars across the middle, with the arms emerging from the ends of that bar. This gives it a kind of elegant structural confidence, like a pinwheel that learned geometry. Spiral arms curl outward through the disk, not as rigid fixed lanes, but as regions of higher density, patterns moving through the galaxy and gathering stars and gas into graceful sweeps. That distinction matters, and it is oddly comforting. The arms are not solid spokes. Stars are not glued into place like decorations on a cake. Instead, stars and gas move through the galaxy, and the spiral pattern acts more like a traffic wave or a grand rotating compression, helping trigger star formation where gas collects and crowds together. So when you picture the Milky Way's spiral arms, you are picturing both structure and flow at once. Nothing is frozen. Nothing is chaotic. It is ordered motion, the same quiet balance you felt in globular clusters, now scaled up to galactic size. Your sun lives in one of the smaller spiral features, often called the Orion Arm or Orion Spur, a minor branch between two larger arms, Sagittarius and Perseus, which is very endearing, honestly. Humanity does not occupy the galaxy's glamorous downtown boulevard. You are in more of a nice suburban spur with decent access to the main routes. Not too crowded, not too lonely, just far enough in the center to avoid some of the more intense galactic drama while still enjoying the view. That distance from the galactic center is about 26,000 light years. So you are not in the middle. You are comfortably off to the side, orbiting with the sun and all the nearby stars in a broad path around the galaxy's heart. One full orbit takes around 225 to 250 million years. This is sometimes called a cosmic year. Since the sun formed about 4.6 billion years ago, it has gone around the Milky Way only about 20 times. 20. Your entire planet, all its oceans and mountains and history and porch lights and lost socks, has circled the galaxy fewer times than many people have reorganized a kitchen drawer. And the pace of that orbit, while immense by human standards, is part of what makes the Milky Way feel so serene. The sun moves around the galactic center at roughly 220 kilometers per second. That is fast enough to cross entire countries in minutes. Yet you never feel it because everything nearby is moving with you. The Earth spins, the Earth orbits the sun orbits the galaxy moves within its local group, and still your tea can sit quietly on a table without complaint. Motion at scale can coexist perfectly with stillness and experience. A useful fact to tuck under the mind like a blanket. The galaxy's disk is where much of the visible drama happens. This is where gas and dust gather in lanes, where younger stars are born, where open clusters sparkle, where nebulae paint those slow-motion murals from before. The disk is relatively thin compared with its width, perhaps around 1,000 light-years thick in the thinner stellar component, though broader when gas and older stars are included. So the Milky Way is a bit like a gigantic luminous record, a spinning disk with a bulge in the middle and spiral patterns traced across it in starlight and dust. Dust is especially important because it both reveals and conceals the galaxy. The Milky Way's dark lanes, those rifts splitting the glowing band, are caused by interstellar dust blocking light from more distant stars. So when the galaxy looks braided or divided in the night sky, you are not seeing absence. You are seeing presence. Great clouds of dust lying between you and the brighter stellar background, closing the curtains here and there. It is another version of what those dark nebulae taught you earlier. Some of the biggest things in space are visible by the light they prevent from reaching you. The central bulge of the Milky Way rises thick with old stars. Toward the constellation Sagittarius lies the direction of the galactic center, but you cannot see it directly in visible light because dust in the disk blocks the view. The heart of your galaxy is hidden behind veils, which is somehow perfect. The most crowded, powerful region in your galactic home does not blaze nakedly in the sky. It remains half concealed, revealed more clearly in infrared and radio wavelengths, like a city center glimpsed through winter fog. At that hidden center resides Sagittarius 8***, the Milky Way's supermassive black hole. Its mass is around 4 million times that of the Sun. That sounds alarming until you remember space is very good at keeping its distances. The black hole is not a vacuum cleaner with boundary issues. It is the deep central anchor of a huge system, and stars orbit close around it in paths astronomers have measured with remarkable precision. To know that there is a dark, massive center holding court at the heart of the galaxy does not disturb the calm. If anything, it deepens the sense that the Milky Way has a secret core, a depth behind the glow. Around the visible galaxy lies the halo, a vast, sparse region containing old stars, globular clusters, and most of the galaxy's dark matter halo, which extends much farther still. The dark matter itself remains invisible, known mainly by its gravitational effects, by the way stars and gas move, by how the galaxy holds together more tightly than visible matter alone would allow. There is something strangely soothing about that, too. The Milky Way is shaped not only by what you can see, but by something hidden and persistent, an unseen structure supporting the visible one. Galaxies, like lives, are not made only of what appears on the surface. And then there is the simple fact of number. The Milky Way may contain somewhere on the order of 100 to 400 billion stars, depending on how you count and what exactly you include. Even the uncertainty is grand. Astronomers are not casually forgetting a couple hundred billion. It is just difficult to census a city when the city is made of suns, dust, and perspective problems. But whichever end of that range you favor, the point is the same. Your galaxy contains more stars than you could ever meaningfully imagine one by one. It is abundance elevated into landscape. Planets likely accompany many of those stars, perhaps most. That means the Milky Way may host hundreds of billions of planets as well, scattered through its spiral arms and inner regions around red dwarfs, yellow suns, double stars, quieter stars, stranger stars, rocky worlds, gas giants, frozen worlds, scorched worlds, worlds under red skies, worlds in dense star fields near cluster-like neighborhoods, worlds circling alone beneath dark open space. The galaxy begins to feel not merely large, but inhabited by possibility. And yet what you actually see from Earth under darkness is still that soft band, a river of unresolved light, a broad breath laid across the heavens. The crowded becomes gentle at distance. The immense becomes luminous haze. That translation from overwhelming fact to peaceful appearance may be one of the Milky Way's greatest kindnesses. It does not ask you to hold all 100,000 light years at once. It lets you begin with a glow. So you picture it now in full, not as a diagram, but as a living structure. Spiral arms winding outward with nebulae and young stars. Globular clusters circling in the halo like ancient lantern towns. Dust lanes threading the disk in dark ribbons. A bar across the center. A hidden core. The sun off to one side, making its long, quiet orbit among countless neighbors. A galaxy both crowded and spacious, intricate and calm, full of motion and yet never hurried. And from your little place within it, you can feel that same lesson returning once more. The biggest things do not always press in. Sometimes they give you room. And once the Milky Way has stretched fully across your imagination, broad and spiraled and quietly rotating, you begin to notice something even more humbling. Your galaxy, for all its hundreds of billions of stars and its hidden central depth, is not the whole story. It is one galaxy among many. Not a rare masterpiece framed alone on a wall, but one luminous city in a vast archipelago of other luminous cities, each with its own structure, history, rhythm, and scale. And some of those neighbors are so immense that even the Milky Way, that great spiral breath of home, begins to look wonderfully manageable. The relaxing part arrives in the shapes first. Galaxies are large beyond everyday thought, but they are not clumsy. They do not lumber through space like cosmic furniture being dragged across a floor. They turn. They arc. They gather themselves into spirals, ellipses, lenticular disks, tidal streams, and soft halos. Even at their grandest, they seem less like machines and more like choreography. The universe, once it starts thinking in galaxies, becomes very graceful. Take Andromeda, the nearest large spiral galaxy to the Milky Way and one of the few deep sky objects you can see with the naked eye under dark enough skies. It appears as a faint, elongated smudge, almost shy. Very typical behavior for something truly enormous. Because that smudge is a galaxy about 2.5 million light years away, containing perhaps 1 trillion stars, larger than the Milky Way in visible extent, and broad enough that if your eyes could register its full brightness and size more easily, it would span several times the width of the full moon in the sky. Instead, it shows up like a quiet brushstroke. Space remains committed to understatement. Andromeda is around 220,000 light-years across, though its extended halo reaches farther still. That means light would take more than twice as long to cross Andromeda's visible disk as it would the main disk of the Milky Way. A larger city of stars, a wider sweep of spiral structure, a greater luminous plane. And yet what makes it soothing is not simply its size. It is the fact that it hangs there so delicately in the night, as if a whole galaxy can present itself as a suggestion. Its spiral arms are less neatly grand than artists sometimes prefer, because real galaxies are often textured, asymmetric, a little rumpled by history. Andromeda has dust lanes, bright knots of star formation, a prominent bulge, and a structure shaped partly by its own long evolution and partly by gravitational interactions with smaller companions. Galaxies are not perfect ornaments. They are living systems with memory, which somehow makes them more beautiful. A slightly weathered galaxy is easier to love than a polished one. And Andromeda is not alone. It belongs with the Milky Way and Triangulum and many smaller dwarf galaxies to the local group, your immediate galactic neighborhood. Already the scale expands from one home to a kind of regional map. The local group spans roughly 10 million light-years and contains dozens of galaxies, most of them dwarfs. Two dominant spirals, the Milky Way and Andromeda, hold much of the mass, while the smaller members orbit, drift, and interact under shared gravity. It is a small village by cosmic standards, but an impressively large village by literally any other standard that has ever existed. There is something restful about thinking of galaxies as social creatures. Not social in the chatty, brunch-organizing sense, more in the gravitational sense. They gather in groups and clusters. They orbit common centers of mass. They exchange material, tug on one another's outskirts, merge over time, and carry entourages of smaller companions. No galaxy is entirely solitary. Even those in quieter regions belong to a larger setting. Space, at its biggest scales, prefers communities. The Milky Way and Andromeda themselves are moving toward one another and will eventually merge, though not for billions of years. Plenty of time to postpone making any plans. When that merger comes, the two great spirals will distort, interpenetrate, fling out tidal tails, and eventually settle into a new, larger galaxy. The word collision gets used, but because the stars are separated by such enormous distances, direct star-on-star collisions are unlikely. It is more a dance of structure than a smash-up of objects, more a slow rearrangement of luminous swarms than a crash in the ordinary sense. Even galactic upheaval is patient. That patience is part of what makes giant galaxies so soothing to hold in mind. Their transformations take hundreds of millions or billions of years. Arms warp, companions are absorbed, halos grow, streams of stars arc around them like silken water, but all so slowly that the whole process resembles breathing more than action. If human life is full of clocks, galactic life is full of tides. Then there are the true giants among galaxies, especially the giant ellipticals found in rich galaxy clusters. These are enormous, rounded or elongated galaxies without the crisp spiral arms of a Milky Way or Andromeda. They can contain trillions of stars, extend across hundreds of thousands of light years, and dominate the centers of clusters like old, luminous monarchs. They are less decorative than spirals, perhaps, but deeply majestic. A spiral galaxy is music. A giant elliptical is architecture. Messier 87 is a wonderful example. It sits near the center of the Virgo cluster and is a colossal elliptical galaxy containing trillions of stars. Its visible form is smooth and diffuse, a vast oval glow with no obvious spiral pattern, just a steady concentration of light thickening toward the middle. It is so massive that it hosts a supermassive black hole billions of times the mass of the Sun. The same black hole whose shadow became famous in the first widely released image of a black hole's immediate environment. But from afar, M87 does not look frightening. It looks composed, a grand old galaxy in an elegant coat. Its size is astonishing enough, yet its surroundings deepen the calm. M87 is embedded in the Virgo cluster, a rich collection of galaxies numbering in the thousands. Picture that for a moment. Not one galaxy, not a few, but a whole region where galaxies gather in abundance, ellipticals and spirals and dwarfs sharing one immense gravitational environment. Intergalactic space is still vast, yes, but the neighborhood has density and structure. The universe keeps scaling up from stars to galaxies, to gatherings of galaxies, and every step remains strangely poised. Some giant ellipticals are even more extreme. IC 1101, often mentioned among the largest known galaxies, is an absolute extravagance. It lies over 1 billion light-years away and may span several million light-years when its enormous diffuse envelope is included. Even allowing for the complexities of defining galactic edges, it is staggeringly large. If the Milky Way is a city and Andromeda a greater neighboring capital, IC 1101 begins to feel like a continent wearing jewelry. It is so extended, so broad, that familiar comparisons lose their grip. A galaxy this large ceases to feel object-like and becomes environment. And yet what would you see from far away? A soft oval glow, not a menace, not a cosmic bulldozer, just a great haze of starlight, smooth and old, suspended in blackness. Again, the largest things arrive with calm faces. Galaxies also have halos, extended regions containing sparse stars, globular clusters, and vast quantities of dark matter. The visible disk, or bright core, is only part of the system. Around it lies an enormous, mostly unseen structure influencing motions and binding the galaxy more securely than visible matter alone could manage. You met this idea in the Milky Way, but among giant galaxies and groups, it becomes even more impressive. The visible beauty is carried inside a much larger invisible framework, as though every bright city in the universe is cradled by a hidden landscape. That hidden structure helps galaxy groups and clusters hold together as well. In the local group, the Milky Way and Andromeda dominate, surrounded by companions and immersed in a shared dark matter environment. In richer clusters like Virgo or Coma, hundreds or thousands of galaxies move through a common gravitational field, tracing arcs and velocities that reveal much more mass than eyes alone would ever suspect. The largest scenes in the universe are partly invisible, and somehow that does not make them cold. It makes them layered. The Coma cluster is especially beautiful to contemplate in that regard. A massive cluster of galaxies far beyond the local group. It contains thousands of members and stretches across tens of millions of light years. At its heart lie giant ellipticals surrounded by swarms of smaller galaxies, all embedded in hot intracluster gas and dark matter. If you could behold it with some impossible wide cosmic vision, it would look like a metropolis of galaxies, a huge congregation of luminous forms floating in relation, each one a city of stars, each one itself immense. And that relation is the key. The biggest galaxies are not merely large in isolation. They become most lovely when seen as participants in larger patterns. Andromeda with its companions. The Milky Way and Andromeda drawing toward each other. M87 anchoring a cluster center. Giant ellipticals reigning in dense galactic courts. Streams of stars torn from smaller galaxies wrapping around larger ones in pale loops. The whole universe at this scale begins to resemble dance notation written in gravity. Even galactic cannibalism, dramatic as the term sounds, unfolds with a kind of stately softness. A large galaxy can absorb a smaller one over time, stretching it into tidal streams and folding its stars into a larger halo. This is not neat or tidy, but from a distance it becomes beautiful. Long ribbons of stars draped around galaxies like traces of old music. The largest galaxies grow partly by gathering others in, not with sudden hunger, but with slow inevitability. Space is ruthless only if you insist on a human timescale. On a galactic timescale, it looks like blending. And perhaps that is why this widening view remains restful. The Milky Way no longer feels like the full measure of home. Home is larger now. It includes Andromeda's broad spiral, Triangulum's gentler disk, dwarf galaxies scattered like satellites of memory, giant ellipticals swelling at cluster centers, whole groups and clusters arranged in gravity's patient hand. Each galaxy is immense. Each is graceful. Each moves within a broader company. Nothing at this scale is truly still, yet nothing feels hurried either. So you let the image settle. Galaxies as great lantern cities suspended in black space, some spiraled like pinwheels, some smooth as glowing pebbles, some so large they begin to resemble weather systems made of stars. Around them, companions orbit. Between them, distance opens like dark silk. Over billions of years they turn, draw near, merge, and reshape themselves, not with violence you can hear, but with choreography you can almost feel. And the more immense the scene becomes, the more oddly gentle it seems, as if grandeur, once big enough, naturally learns how to move with quiet grace. And from those giant galaxies, drifting in groups and clusters like lantern cities across the dark, you widen the view again until even clusters begin to look like neighborhoods. This is where scale becomes almost medicinal, because the universe stops presenting itself as a scattered collection of things and begins revealing a pattern. Not a perfect pattern, not the neat grid some anxious part of the human mind might secretly prefer, but something far lovelier, a grand cosmic web, threaded across unimaginable distances, with dense knots where galaxies gather, long filaments where matter stretches between them, and vast, empty-looking regions where almost nothing shines at all. If galaxies were individual towns and clusters were sprawling metropolitan regions, then the cosmic web is the map of continents and oceans combined. Except even that comparison is far too cozy. This structure spans hundreds of millions of light years, then billions. It is the largest visible arrangement of matter in the universe, and yet its beauty comes from the same gentle trick space has been using all along. It looks soft. It looks airy. It looks almost biological, like frost branching on glass, like neural tissue, like a web touched with dew, like roots spreading through dark soil. The universe, at its biggest, starts borrowing shapes you already trust. That resemblance has fascinated people for years. The cosmic web is not literally a brain, not literally a root system, not literally lace. But the visual echoes matter. They give your imagination something to hold onto while the numbers wander off into absurdity. Because the truth is that galaxies are not distributed randomly through space. Gravity, working over billions of years on tiny differences in the early universe, pulled matter into filaments and nodes. These filaments became highways of galaxies and gas, while the spaces between them emptied out into vast cosmic voids. So the universe, once smooth enough in its youth, slowly gathered itself into a kind of structure that feels both architectural and organic. A filament can stretch for hundreds of millions of light years. Let that soften into your thoughts for a second. Not a star, not a galaxy, not even a cluster, but a thread-like arrangement of galaxies and matter extending across distances so large that light itself needs ages to travel from one end to the other. And yet, thread-like is relative. These filaments are not little strings. They are colossal corridors, broad regions where galaxies collect, interact, and move within the larger scaffolding of the universe. The relaxing fact here is that the largest structure is not a solid wall closing in on you. It is a web with room in it. Enormous room. Space at this scale is all relationship and separation, gathering and openness, density and drift. Nothing feels cramped. Even where the web is richest, the distances remain majestic. The universe knows how to be connected without becoming crowded. Frankly, a very healthy model. At the intersections of these filaments lie superclusters and cluster complexes, places where galaxy groups and clusters accumulate into especially rich regions. Your own local group, containing the Milky Way and Andromeda and their smaller companions, belongs to a larger flow of structure. It is part of a larger supercluster environment, one region among many in the broader web. Once you notice that, home becomes even stranger and more beautiful. You're not merely in a galaxy. You are in a galaxy within a group within a supercluster within a filamentary cosmos. The address section on that envelope would be exhausting, but emotionally it is wonderful. Superclusters themselves are not simple, tightly bound objects in the way a star cluster is. They are more like broad regions of enhanced density, large-scale associations of galaxy clusters and groups that trace the web's grander contours. Some are still drawing together in parts, while others are more like temporary patterns in the ongoing expansion of the universe. Even at the largest scales, things are dynamic. Gravity gathers, expansion stretches, the web evolves slowly and with astonishing patience. And then there are the walls. The name sounds dramatic, but the effect is curiously peaceful. A galaxy wall is a vast sheet-like arrangement of galaxies, one of the biggest recognizable patterns in the cosmos. The Sloan Great Wall, for example, stretches over 1 billion light-years in length. 1 billion light-years. The phrase barely fits inside language without needing to loosen its collar. This is not a wall like brick or stone. It is a grand flattening of cosmic structure, a broad assembly of clusters, groups, and galaxies tracing one colossal feature in the web. Picture a shoreline seen from orbit, except the shoreline is made of galaxies, and the sea beside it is deeper than imagination can comfortably furnish. There is something lovely about calling it a wall, because that gives your mind a surface to rest against, but in truth it is still airy, still made mostly of vast separation. Galaxies line up in this giant structure, yes, but with enormous gaps between them, and even the clusters that define the wall are islands in a much greater dark. The largest solid-looking things in the universe are still largely openness. The web is substantial without ever becoming heavy. Another immense feature, the Hercules Corona Borealis Great Wall, has been proposed as an even larger structure inferred from certain observations, on scales so extreme they make astronomers raise their eyebrows and then very sensibly check their math again. Whether every claimed giant structure fits neatly into current models is part of ongoing science, which is one of the quietly charming things about cosmology. The universe keeps saying, here is a pattern the size of several 100 million or even billions of light years, and the scientists reply, delightful. We will now spend years arguing carefully about what exactly we are looking at. That careful arguing never ruins the beauty. If anything, it deepens it. The biggest things in space are not always easy to define because scale starts blending in a process. Filament wall, basin flow void. These are not furniture pieces with crisp labels attached. They are large-scale arrangements of matter responding to gravity and expansion over cosmic time. The names are handles, not boxes. And opposite the filaments and walls are the voids, which may be the most relaxing large-scale structures of all. A cosmic void is a region of space containing far fewer galaxies than average, vast expanses where the web thins out and luminous matter becomes sparse. Some voids span tens or even hundreds of millions of light years. These are not perfectly empty regions. There are usually still a few galaxies, a little matter, the whisper of structure. But compared with the denser filaments and clusters, a void is spacious almost beyond belief. You might expect emptiness on that scale to feel bleak, but it often feels like relief. A void is room, a pause in the composition. The darkness between the bright structures is not a failure of decoration. It is part of the design. Without the voids, the filaments would not look like filaments. Without silence, music cannot breathe. Without the dark intervals, the universe's bright architecture would blur into noise. One especially famous example is the Boötes Void, a huge underdense region discovered decades ago, roughly 300 million light-years across. That is a volume of such astonishing spaciousness that it almost becomes humorous. Human beings can feel emotionally challenged by a quiet elevator ride. Meanwhile, the universe casually maintains regions hundreds of millions of light-years wide with comparatively few galaxies in them, and never once apologizes for the ambience. The beauty of the cosmic web lies in this contrast. Nodes rich with clusters, filaments linking them like luminous roads, walls stretching like continental shelves of galaxies, voids opening like dark lakes between them. When cosmologists simulate the growth of structure in the universe, matter condenses into these patterns with an elegance that can look almost like time-lapse frost spreading over a window. Tiny fluctuations in the early universe become, through gravity's endless patience, the largest structures known. The biggest things are born from the gentlest differences, amplified over ages. Dark matter plays a leading role here as well, shaping the web from behind the visible scene. Ordinary matter, the stuff of stars, planets, nebulae, and you, falls into the gravitational framework dark matter provides. So the visible cosmic web is partly like light settling into an invisible sculpture. The deepest architecture of the universe cannot be seen directly, only traced by its effects, by the way galaxies gather and move. There is something deeply soothing about that hidden support. The visible universe is carried on a framework larger than sight. And because light takes time to travel, observing distant parts of the cosmic web is also observing the past. The farther away you look, the earlier in cosmic history you are seeing these structures. Some remote filament or cluster is not only far in distance, but old in appearance. Its light beginning the journey long before Earth had cities, before mammals, before perhaps even complex life depending on how far out you go. The web is not static in time any more than it is in space. It is a record unfolding toward you. That makes the whole structure feel less like a frozen map and more like weather of the grandest scale. Slow, yes, unimaginably slow, but still changing. Galaxies stream along filaments toward denser nodes. Clusters merge. Voids expand as the universe itself expands. Matter rearranges on scales so large that the verbs barely know how to handle themselves. Flow, gather, stretch, thin, deepen. These are soft words, and they suit the scene better than anything harsher. You can almost feel the emotional lesson in it. The universe's largest pattern is not one giant lump. It is an arrangement of connection and emptiness, of gathering and spacious release. It has places of company and places of solitude, dense luminous knots and broad silent reaches. It does not choose one mood and force everything into it. It makes room for both. So you rest for a while in that image. A universe threaded like dew on silk, walls of galaxies rising without heaviness, filaments spanning the black, vast voids opening like calm breaths between bright regions. The biggest structures in existence do not roar. They extend. They do not crowd the sky. They organize it. And at this scale, with everything stretched out into patterns too large for urgency, even emptiness begins to feel kind. The cosmos, immense beyond any porch light beginning, now looks uncannily alive and deeply at rest at the same time. And from those webs and walls and immense dark voids, your view widens one last time until even the largest structures begin to soften into part of something greater still. This is where you arrive at the observable universe, the whole vast region from which light has had time to reach you since the beginning of cosmic history. Not the whole universe, perhaps, because the whole may extend far beyond what you can ever see, maybe vastly beyond, maybe endlessly beyond. But this is the edge of the seeable, the limit of your cosmic window, and there is something deeply calming about a limit that is not a wall, but a horizon. A horizon is a tender kind of boundary. It is not slammed shut. It simply marks where seeing gives way to mystery. The observable universe is not centered on Earth because Earth is special in any grand cosmic sense. It is centered on you only in the practical way any view is centered on the viewer. Everywhere in the universe, any observer would see their own observable sphere around them, bounded by the age of the cosmos and the travel time of light. That means your horizon is personal without being privileged. The universe allows you your own center point for looking, while quietly reminding you that everyone else gets one too. Very fair, very elegant. The age of the universe is about 13.8 billion years, and that sounds, at first, like it should make the observable universe 13.8 billion light years in radius. But space, in its usual charming habit of refusing to be simple just when you think you've got it, has been expanding while the light traveled. So the most distant regions whose ancient light can reach you now are much farther away than 13.8 billion light years in present-day distance. The radius of the observable universe is roughly 46 billion light years, making the full diameter around 93 billion light years. 93 billion. It is one of those numbers that does not fit in the mind, so much as stretch it gently until resistance becomes pointless. And yet, as always, the emotional effect does not have to be panic. It can be relief. Because once the scale becomes that large, you're no longer trying to dominate it with understanding. You're simply resting inside the fact that reality is spacious beyond measure. Imagine a sphere centered on you, not small and local like the moon's orbit, not broad and stately like the Milky Way, not even filamentous and immense like the cosmic web, but a sphere enclosing every galaxy whose light has had enough time through the expanding universe to become part of your story. Inside it are perhaps 2 trillion galaxies by some estimates, though many are faint, tiny, and distant beyond ordinary direct observation. 2 trillion galaxies, every one containing stars, many containing planets, countless histories of light. The observable universe is not merely big. It is abundance raised to a level so extravagant that counting itself begins to feel quaint. And the strange, sleepy beauty of this final scale is that you never see it all at once. You infer it. You build it from light arriving across ages. You gather it piece by piece through telescopes, spectra, redshifts, and a patient willingness to let the cosmos explain itself slowly. The biggest thing you can see is known mostly through softness. Dim smudges, ancient radiation, faint patterns in matter and light. The universe saves its most enormous truths for the quietest signals. One of those signals is the cosmic microwave background, the afterglow of the early universe, a faint bath of radiation filling all of space. It comes from a time when the universe was only about 380,000 years old, when it had cooled enough for light to travel freely for the first time. Before that, the cosmos was hot, dense, and opaque, a glowing fog where light could not get far without being scattered. Then, as expansion cooled things down, atoms formed, the fog cleared, and light began its journey. That ancient light has been traveling ever since, stretched by cosmic expansion into microwaves. When you detect it, you are seeing the oldest light that can be seen directly. There is something almost impossibly soothing about that. Space is filled with a whisper from infancy. Every direction you look, beyond stars and galaxies and clusters and voids, you eventually reach this gentle relic glow. The universe has a baby picture, and it is everywhere. That afterglow is astonishingly uniform, which tells you something profound. On the largest scales, the universe is remarkably even. Yes, there are galaxies, clusters, walls, and voids. Yes, structure grows and flourishes. But zoom out far enough, and the cosmos smooths itself. It becomes statistically homogeneous, broadly the same in every direction, like a vast fabric with tiny wrinkles rather than dramatic folds. The largest thing is not chaos. It is calm. The deepest backdrop behind all the grand architecture is balance. Those tiny wrinkles matter, of course. Slight variations in the early universe became the seeds of everything that followed. The galaxies, the nebulae, Jupiter's storms, the sun's warmth, the iron in your blood, the porch light from the beginning of this long, slow journey. All of it traces back to minute fluctuations in a nearly uniform ancient sea. The whole magnificent cosmos grew from something almost smooth. It is one of the gentlest facts in science. Complexity can bloom from subtle beginnings. A tiny unevenness can become a universe rich enough to contain stars that make suns blush and clouds larger than imagination, and galaxies dancing in clusters and listeners lying awake beneath ceiling fans. Expansion is the other great quiet presence here. The universe is not static. Space itself stretches. Galaxies on the largest scales recede from one another, not because they're all flying through pre-existing emptiness like sparks from a fire, but because the fabric of space between them expands. The farther away a galaxy is, the faster it tends to recede. This is not the violent motion of something being chased. It is the long, smooth opening of room. The universe is giving itself more space. And that makes the horizon especially poignant. Some galaxies are so distant that the light they emit now will never reach you, because the expansion of space carries them away too quickly on the largest scales. You see them as they were, when a universe was younger and smaller, but their present selves may already lie beyond future contact, drifting deeper into unreachable distance. This sounds sad if you phrase it badly, but tonight it feels more like mist. The universe does not owe you total visibility. It offers a generous window, and beyond that window lies more, quietly unclaimed. The observable universe is therefore both immense and incomplete. It is everything you can, in principle, see, and not everything that is. A marvelous arrangement. Mystery remains built into reality, not because you have failed, but because horizons are part of the design. There is always more beyond the furthest glow. And perhaps that is the most relaxing fact of all. The universe is larger than your knowledge, larger than your maps, larger than your questions, larger than every structure you have visited tonight. Bigger than Jupiter's weather, bigger than the sun's steady heart, bigger than Betelgeuse and Ui Scuti and those painted nebulae. Bigger than globular clusters and the Milky Way's long spiral breath. Bigger than Andromeda and giant ellipticals and the web of galaxies stretched over the dark. All of it, every layer, every beautiful scale, resides within a still larger horizon. So when you think back now to where this began, with the roofline, the cool air, the little porch light trying its best against the night, the contrast no longer feels comic. It feels intimate. The same universe that contains trillions of galaxies also contains the exact smallness of a quiet room. The sound of a fan nearby, the warmth of a blanket, the private thought moving gently through your mind right now. Enormity has not erased nearness. It has made room for it. You are small, yes, but not excluded. You are local, but not separate. The atoms in you are forged in stars. The planet under you orbits a perfectly ordinary sun. That sun travels one minor arm of one galaxy among trillions, and still here you are, able to notice the whole strange layered arrangement from inside it. Consciousness is a very soft lamp in a very large house, but it is still a lamp. And now the pacing softens even more. You let the numbers loosen and drift away first. You do not need to hold 93 billion light years in your hands. You do not need to keep count of galaxies, or remember which giant star reached past which orbit, or where exactly the Sloan Great Wall stretches through the dark. The facts have done their work. They have opened the room. They have widened the ceiling of the mind. That is enough. You picture only the gentlest images now. The pale river of the Milky Way, the warm bands of Jupiter, the sun laying light across a table, a red supergiant glowing like an ember. pillars of dust rising in a nebula. A globular cluster like an old town made of lanterns. Andromeda hanging faintly in the dark. Filaments of galaxies like dew on silk. The ancient afterglow filling all directions with a whisper from the beginning. And beyond even that, a horizon. Not a hard edge, not a door shutting. Just a soft fading where sight gives way to stillness, and stillness gives way to more. You can rest there. You can let the universe be vast without needing to finish it. You can let mystery remain kind. The roofline is back now, somewhere below the stars. The night is quiet again. The great structures keep turning without sound. The galaxies keep their long distances. The old light keeps arriving. And you, here in your small, safe place, do not need to travel another inch. The biggest things in space have already come to you in the only way they can, as light, as thought, as wonder softened into calm. So let everything settle. Let the web grow faint. Let the galaxies dim to a hush. Let the final horizon blur like breath on glass. And let sleep find you the way starlight does, gently, patiently from very far away, until it is suddenly here.